After 40,000 years under the faint light of an unknown star, a piece of ancient metal floats in the cold, dark expanse of interstellar space. This is Voyager 1, which human civilization sent in 1977. Suddenly, an unknown civilization has spotted this spacecraft. Their eyes fall on a shiny, gold-plated golden record on which the sounds of Earth, music, and many pictures are recorded. They touch it, and in an instant, the voices of human civilization from millions of years ago echo before them. But will they be able to understand it? And will this message really be able to tell our story? This scene leads us to a question. In 1977, when Voyager 1 and Voyager 2 bid farewell to our solar system with the golden record, they carried a time capsule of our world with them. But today, if we launch Voyager 3, would we send such a golden record again? Or will the technology of our digital age help us do something else, something more complex, something bolder? How will we tell our story to those distant civilizations in the infinite darkness of interstellar space? And will there really be anyone out there to listen to our story? In 1977, when Voyager 1 and Voyager 2 left Earth, they were not just machines, they were messengers of humanity. They were sent to explore the outer planets of the solar system: Jupiter, Saturn, Uranus, and Neptune. A rare planetary alignment gave them the opportunity to hop from one planet to another using gravity assist. Voyager 1 visited Saturn's moon Titan and then left the solar system, heading out into interstellar space. But Voyager 2 traveled to Uranus and Neptune, and then it too set out on an endless journey beyond the solar system. But the real strength of these spacecraft was not in their discoveries, but in the message they carried with them, the golden record. This idea belonged to Carl Sagan and his wife Anne. With the help of Frank Drake, John Lomberg, and National Aeronautics and Space Administration, this record included 115 pictures, sounds of nature, music, greetings in 55 languages, and messages from American President Carter and United Nations Secretary General Waldheim. It was a phonograph record made of gold-plated copper, and it came with a stylus. It was meant to be played at 16 2/3 revolutions per minute, not the usual 33 revolutions per minute, to store as much data on it as possible. This record was much more advanced than the simple metal plaques on Pioneer 10 and 11, which were launched in 1972 and 1973. The Pioneer spacecraft only had the name of the spacecraft and the origin of our Earth written on them, but the golden record was a complete story in itself, of Earth, of our humanity, and of our hopes. It was placed in an aluminum cover which had a layer of uranium-238 on it. Uranium was used for two reasons. It is 5 times more effective than lead at blocking cosmic rays and X-rays, and its decay can help determine the age of an unknown civilization's record. The golden record was not just a scientific experiment, it was a bold step, it was a risk. Should we share our information with unknown civilizations? Some believe that it could be dangerous, but the spacecraft is moving so slowly at about 56,000 to 61,000 kilometers per hour that it would take 77,000 to 84,000 years just to reach our nearest star, Proxima Centauri, and it's not even heading toward Proxima Centauri. First, it will have to cross the Oort cloud, which is the outer shell of the solar system, and that alone will take about 20,000 years. This is such a long period of time that even our imagination can't grasp it. 20,000 years ago, humans were in the Stone Age, and today, in the era of the digital revolution, our technology has brought us so far. If we survive for another 20,000 years, we might become a spacefaring civilization ourselves. But the question remains, if we send Voyager 3 today, will we send something like the golden record again? Or will our technology show us a different path? Will our message still be that simple, or will we want to throw something more complex into the cosmic ocean? The golden records of Voyager 1 and Voyager 2 are among the most daring attempts of human civilization. Even though we sent them off fully protected, will these records really last for eternity? Or will the cruel forces of the cosmic ocean silence them forever? As far as interstellar space is concerned, it's not empty at all. It's a place where interstellar dust particles, even smaller than a micrometer, collide with Voyager at speeds of about 50,000 to 70,000 kilometers per hour. Each collision creates a tiny crater which can gradually damage the surface of these spacecraft and possibly even the golden records. These particles are so small that their size is about 1/1000th of a millimeter, but their speed makes them deadly. In addition, charged particles from the solar wind and cosmic rays coming from supernovae or black holes can knock atoms out of the crystalline structure of the golden record. Over millions and billions of years, this process can weaken the records. National Aeronautics and Space Administration had already understood this danger, so the golden records were placed in an aluminum cover coated with uranium-238, which will protect them from the harsh environment of interstellar space. An infographic has also been made on this cover, which explains how to play the record. But the question is, how will an unknown civilization, which might be using completely different technology, be able to understand it? The golden record is based on the technology of the 1970s. Images with 512 vertical lines and analog sound. It was a marvel of its time, but today it seems outdated. Scientists like Nick Obag at the Captain Astronomical Institute have calculated how the different paths of the Voyager spacecraft will affect their golden records. Voyager 2 is heading toward a red dwarf star called Ross 248, which is about 1.7 light years away, and it will take more than 30,000 years to reach there. Although it will encounter less interstellar dust, Voyager 1, which will pass through denser dust clouds in the galaxy, may have its cover wear out more and faster, increasing the risk of damage to the record. Scientists estimate these records could last around 5 billion years. But by then, the Milky Way and Andromeda galaxies will have collided. What will happen to the Voyagers in this collision? Ober's model suggests that there is a chance the Voyagers could be thrown out of the new galaxy during this time into intergalactic space, where high-energy cosmic rays will become even more dangerous. Will the golden record survive this? And if we send Voyager 3, will we rely on such analog technology again? Or will our modern technology show us a new path? The golden record had the courage to carry the story of humanity into interstellar space in the 1970s. It was a phonographic record made with the most reliable technology of that time. But today, we are living in an era of digital revolution. If we launch Voyager 3, will we rely again on such analog technology, or will our modern technology show us a path that is more powerful, more complex, and more risky? In today's world, data storage means terabytes, petabytes, and nanoscale technology. Fused quartz disks which are written with femtosecond lasers. This could be a revolutionary option for Voyager 3. A 12-centimeter quartz disk can store 360 terabytes of data. That's millions of times more than the golden record. And this disk can last for 14 billion years, longer than the lifespan of our sun. The golden record included 115 pictures, music, and greetings in 55 languages. But on a quartz disk, we can store entire books, videos, scientific data, and maybe even a summary of the entire internet. But this is where a mysterious challenge emerges. Data is written onto a fused quartz disk at the nanometer scale in 2 optical dimensions and 3 spatial dimensions. To read that data, a technique is required that perhaps only an advanced civilization might possess. Conversely, the golden record's simplicity was their strength. With a stylus and some instructions, anyone could play it. But the quartz disk would require laser technology and nanoscale decoding to read it. Are we ready to take the risk that some unknown civilization might not be able to understand our complex technology? There's another question. If we send an electronic reader with Voyager 3, will it be able to withstand the harsh conditions of interstellar space? Cosmic rays, interstellar dust, and charged particles can destroy any electronic devices over millions of years. Even if the fused quartz disk lasts for 14 billion years, the equipment to read it might become useless in just a few thousand years. Then our message, no matter how detailed it is, will be lost in silence forever. The strength of the golden records was their simplicity. They were like vinyl records that anyone could understand without complex technology. But today, our digital world gives us the opportunity to send more data, more stories, and more complex messages. But the question question is, will we choose quantity or simplicity? Will we choose for our message to reach every civilization or only the most advanced ones? And if we send Voyager 3, will our message become a shining star in the cosmic ocean that everyone can see, or will it remain as silent debris? The golden records of Voyager 1 and Voyager 2 dared to send the story of human civilization into interstellar space. This was an attempt filled with hope and curiosity. But if we launch Voyager 3 today, would we dare to send a similar message again? But this time, the question is even bigger. Should we reveal our existence to the universe? Some people had warned us when we were making the golden records. Should we give unknown civilizations our information, like our location, our culture, and our weaknesses? Could a hostile alien civilization misuse this information? But today, this question has become even more serious. Voyager is much slower compared to the speed of light. It will take more than 20,000 years just to cross the boundary of the outer shell of our solar system, that is, the Oort cloud. This means that if any civilization finds these spacecraft within our lifetime, then maybe they are already present in our solar system. But this risk is not limited to just hostile aliens. If we send a new message with Voyager 3, like the fused quartz disk, which can store 360 terabytes of data, then what will happen if it somehow falls into the wrong hands? Today, in our digital ecosystem, data brokers, personalized ads, and online tracking have turned our personal information into a business. Our email, name, address, age, and profession are sold just to exploit us. If this is a security threat, even on our own planet, then sending the entire story of human civilization into interstellar space could be even more dangerous. This ethical question is just as profound. Do we have the right to decide whether the story of our civilization should be sent into the universe? If we send our entire digital history with Voyager 3, our wars, our mistakes, our achievements, are we unknowingly exposing our weaknesses, or is it our responsibility to leave our voice in the cosmic ocean to show that we existed, we dreamed, and we tried? Will the message of Voyager 3 become our hope or our greatest mistake? Voyager 1 and Voyager 3 have sent a time capsule in the form of golden records, which could reach an unknown civilization millions or perhaps billions of years from now. But if we launch Voyager 3 today, would we choose such simplicity again, or would we opt for the powerful technology of the digital age? Imagine billions of years from now, when the Milky Way and Andromeda galaxies collide, these Voyagers, or at least their golden records, might still be floating in this cosmic ocean. Interstellar dust and cosmic rays might have worn them down, but those records, protected by uranium-238, will be wandering somewhere, preserving the last traces of human civilization, waiting for someone. If some civilization finds them, they will hear our laughter, our lives, our music, and our dreams. They will know that a small planet, a tiny blue dot, once wanted to reach the stars. But what will Voyager 3's message be? As Carl Sagan said, our message should be very simple so that every civilization can understand our story. Or will we rely on techniques like nanoscale, knowing that perhaps only the most advanced civilizations will be able to read it? And will we take the risk that our location, our vulnerabilities might reach a dangerous civilization? This is a puzzle that forces us to think about how to define our place in the universe. This story is not just about the Voyagers, it's our story. It's the story of that curiosity which gave us the courage to look beyond the Oort cloud towards stars like Ross 248 and perhaps even into intergalactic space. In 1977, National Aeronautics and Space Administration launched two of the most ambitious missions in human history, Voyager 1 and Voyager 2. These twin spacecraft were designed to study the outer planets, and after that, they were to move forward exploring outer space and interstellar space. It's been more than 4 decades, and these Voyager spacecraft are still transmitting their valuable data back to Earth. They are moving further into the dark corners of space where nothing made by humans has ever reached before. Voyager 1 is now more than 14 billion miles away from Earth, while Voyager 2, also traveling in interstellar space, is a little behind, having covered a distance of 12 billion miles. For us, these spacecraft have become symbols of human curiosity and our obsession with uncovering the mysteries of this universe. But how long will this mission continue to explore the infinite universe? As this mission keeps moving forward, what will its end be? How will the incredible mission of the Voyagers move toward its conclusion? What could be the possible end scenarios for this greatest mission of the Voyager spacecraft? As these spacecraft move further into the cosmos, what challenges will National Aeronautics and Space Administration have to face? After all, what are the limits of our technology? We will find out in today's informative video. The current status of the Voyagers. Before we talk about the possible and potential end scenarios of the Voyager spacecraft, we need to know the current position of the Voyager spacecraft, and since its launch in 1977, how far has this mission reached? Voyager 1 and Voyager 2 were originally designed for a grand tour of the outer planets of our solar system, which was to take place during a rare planetary alignment. This planetary alignment was such that the outer planets of the solar system were going to align in a way that a single mission could perform flybys of all of them together. And this alignment is so rare that it only happens once every 176 years. So keeping this alignment in mind, two missions were designed. The first was Voyager 1, whose primary mission was to fly by Jupiter and Saturn and transmit the valuable data collected there back to Earth. The second mission was Voyager 2, whose journey was going to be a bit longer compared to Voyager 1. Because it was going to pass by all the major planets, Jupiter, Saturn, Uranus and Neptune, and also explore their moons. Both spacecraft performed excellently in their tasks and successfully completed their respective missions. Not only that, both spacecraft performed far better than the scientists had expected, and they also sent us the latest images of those planets, groundbreaking data, and pictures of their moons, which kept improving our understanding of the outer planets of our own solar system even more. After completing their primary mission, both spacecraft started their extended mission and set out towards interstellar space. In the year 2012, Voyager 1 became the first human-made object to enter interstellar space. That means this spacecraft was the first to cross the heliopause and step into interstellar space. The heliopause is the boundary after which the sun's influence fades away, and beyond that, the interstellar medium begins. Meanwhile, Voyager 2 entered interstellar space in the year 2018. As of now, both of these spacecrafts are operational and are continuously sending us data. However, sometimes we face problems communicating with them, and occasionally we also see glitches in these spacecrafts. But somehow, National Aeronautics and Space Administration manages to communicate with them. The farther these two spacecrafts go from us, the longer it takes to communicate with them, and it is becoming increasingly challenging. The signals received from both these spacecrafts are also very weak, which becomes the next big challenge for National Aeronautics and Space Administration. The signal received from Voyager is 20 billion times weaker than the energy required to run our digital watches. Even after so many challenges, National Aeronautics and Space Administration captures these signals with its deep space network, and in this way, we are able to collect scientific data about the interstellar medium and the outer regions of our solar system. Both Voyager spacecraft are equipped with radioisotope thermoelectric generators, or RTGs, to power the instruments on board. These generate electricity from the heat released by the decay of plutonium-238 over time. The output power generated by the RTGs keeps decreasing, making it impossible to keep all the spacecraft's instruments running. That's why National Aeronautics and Space Administration has very carefully managed the spacecraft's power consumption. To keep the spacecraft running for a long duration, National Aeronautics and Space Administration has turned off all non-essential instruments from time to time to conserve the spacecraft's energy. But as Voyager continues to move forward, its power levels will eventually become so low that it won't be able to run any of its instruments. Eventually, we'll lose contact with Voyager when it can no longer communicate. But the question is, what will happen then? Will this historic mission come to an end at this point? Running out of power. The most natural end of the Voyager mission is that the Voyager spacecraft will eventually run out of power. The radioisotope thermoelectric generator, which is the power source for both of these spacecraft, is steadily losing its power because we cannot affect the natural decay process of plutonium-238 in any way. That means you can say that ever since these radioisotope thermoelectric generators were manufactured, they have been losing their power. And a time will come when these radioisotope thermoelectric generators will not be able to generate the electricity needed to run the spacecraft's instruments. Then the Voyagers will go silent forever on their journey. National Aeronautics and Space Administration estimates that the radioisotope thermoelectric generators on the Voyagers can currently generate enough power to run 1 or 2 onboard instruments until 2025, and after that, the power levels will drop below the minimum required threshold to operate the spacecraft systems. And when this happens, the Voyagers will not be able to communicate with our Earth. The Voyagers won't be able to send us signals, nor will they be able to precisely align themselves toward Earth to send signals. Because all these tasks are performed by the instruments on the Voyagers, when this happens, all the scientific instruments on the Voyagers will stop working. But even after losing power, Voyager will continue its journey in this vast universe just like that. It will quietly dedicate itself to fulfilling a very ambitious mission sent by humans, the Golden Records. Yes, the most precious thing on Voyager. We humans have sent sounds from Earth, pictures, our life, culture and daily activities on a phonograph record on both Voyager spacecrafts. Besides this, there are many signals and messages for aliens through which they can learn about life on our Earth, Earth's location and ways to contact us. If these spacecrafts are found by some highly advanced intelligent extraterrestrial life, then this mission will truly be accomplished. But until then, it will keep traveling through the universe, representing our planet, us humans and our humanity, that is, the human race. It will silently keep carrying our message to other parts of the universe. However, we will never know what will happen to the Voyagers after contact is lost. Whether these spacecrafts will actually deliver our message to aliens or something else will happen to them, a deep mystery will always surround this. But one thing is certain, this journey could continue for thousands, millions, or even billions of years to come. Interstellar collision. Another possible scenario is that the Voyager spacecraft could collide with an object in interstellar space. However, the chances of this happening are quite low because space is much bigger than we can imagine, and compared to that, spacecraft are quite small. In such a situation, it's almost impossible for them to collide head-on with any object. Interstellar space is not completely empty, but it is definitely very sparse, meaning its density is so low that in interstellar space there is only one particle in a cubic centimeter, which is much less than the density of our solar system. That's why in the vast expanse of the universe, the chances of a spacecraft colliding with any object are very low. Even if Voyagers collide with any object in interstellar space, it will most likely be a tiny grain or an interstellar dust particle. And if it collides with such a small particle, nothing will happen to our spacecraft. The small size of the particles and their small relative speed won't be able to cause much damage to our Voyagers. In fact, if you see, Voyager 1 and Voyager 2 collided with many such particles while leaving our solar system, but these didn't have any effect on the Voyager's performance. But yes, if the Voyagers were to collide with a large object like a small asteroid or a comet, the results could be quite disastrous. Right now, the Voyagers are traveling through interstellar space at approximately 17 kilometers per second. And at such a speed, if they collide with even a small object just a few centimeters in diameter, the event would be catastrophic. This impact would destroy the spacecraft, its pieces would scatter as debris all over space, and such an end would be quite emotional for us. We know that in such a collision, nothing would be left of the Voyagers, but the chances of this happening are quite low. Voyager is traveling through those parts of the universe that are almost empty, where the chances of a collision are nearly zero. And even if that happens, it will be millions of years from now, and by then, Voyagers will probably have become chapters in history books on Earth. Entering a solar system, we can add another strange scenario to Voyager's journey. It's possible that during their journey, the Voyagers might enter another solar system, and that could be the final destination of their journey. However, we are considering this entire scenario as hypothetical, and it would take millions of years for something like this to happen. But this would prove to be a new turn in the Voyager's journey. Both spacecraft are on their decided trajectory in interstellar space. They are moving forward in such a way that Voyager 1 is heading towards the constellation Ophiuchus and Voyager 2 is heading towards the constellation Sagittarius. If these spacecraft keep moving at the same speed, in the next 40,000 years, Voyager 1 will reach within a 1.6 light-year radius of a known star, Gliese 445. Meanwhile, Voyager 2, traveling through this infinite universe, will be within a 4.3 light-year radius of a star called Ross 248 after about 296,000 years. Although these distances might seem very large to us, if we look at it on a cosmic scale, they are nothing at all. If these spacecraft get very close to those stars or reach right near a star system, their trajectory will change because of that star. It's possible that these spacecraft might pass very close to the celestial bodies present there. In such a scenario, the Voyagers will become the first man-made objects to enter another star system. Even though our Voyagers will visit another star system, by that time, due to the lack of a power source, they will remain completely inactive. By the time they reach that star system, their power source will not be generating any energy at all. That's why they won't be able to transmit any signals to those celestial bodies or to Earth. That means even if this happens, we will never know what happened to the Voyagers in their final moments. If there is intelligent life present in that star system, they will definitely notice the Voyagers, and seeing an artificial object like Voyager, they might even try to capture it. So what will happen when this scenario actually comes true? Discovery by an alien civilization. The idea of the Voyager spacecraft falling into the hands of an alien civilization is one of our most fascinating thoughts. This is one of the most exciting possibilities, that one day the Voyager spacecrafts will be discovered by some intelligent alien civilization. Both spacecrafts, Voyager 1 and Voyager 2, carry a golden record, which is a message sent from us Earthlings to those extraterrestrials. The golden record contains sounds and images that represent life here, that is, life on this earth. Greetings have been sent in 55 languages. Music from different cultures, pictures of people and animals, and images of Earth's landscapes are also included in the Golden Record. In addition, there is also a message from the United States President at that time, Jimmy Carter, in which it is hoped that this mission will spread the story of human civilization's existence to every place and every corner of this universe, and that other existing aliens will come to know that there is someone living on Earth as well. And we humans are very eager to communicate with anyone in this universe. Although the chances are almost zero that any alien civilization will be able to discover the Voyagers, still this possibility makes all of us curious. Even if we assume that an alien civilization has discovered one of these spacecrafts, we will never be able to find out about it. The challenge is also that those advanced aliens will have to decipher the messages sent on the golden records. Only after that will those aliens be able to learn about us and the life thriving on our Earth. And in this way, the Voyagers are representing our human civilization in this infinite universe. What if we say that the Voyagers are never found by aliens? Even if that happens, the Voyagers will continue to wander through this infinite universe, carrying the message of our humanity. It is this spirit of exploration that makes us humans exceptional. The Golden Record is a reminder of how we are always ready to explore this universe and connect with it. We don't want to be alone in this infinite universe. We are looking for a companion who won't let us feel alone on this cosmic scale. And we hope that one day our efforts will definitely succeed. Launched in 1977, National Aeronautics and Space Administration's Voyager 1 and Voyager 2 spacecraft have embarked on an extraordinary journey for our human civilization. Today, traveling through this infinite universe, they have gone much farther than any other man-made object. The Voyager mission was originally designed for just a 5-year mission period to explore Jupiter and Saturn. But the Voyagers performed far better than scientists had expected. It completed all its missions on time, and then it was sent again on an endless journey through this infinite dark universe for further missions. And today, Voyager 1 is about 14 billion miles away from our Earth, and Voyager 2 isn't far behind either, and both are continuously traveling through this infinite dark universe. But the question is, how did National Aeronautics and Space Administration manage to keep these spacecraft operational for such a long time, despite the vast distance and harsh space conditions? Keeping them alive also required cleverness, skill, talent, and a bit of luck. Carefully managing power, continuously providing accurate software updates, and overcoming technical challenges. The Voyager mission team has made every possible effort to keep these spacecraft's historic journey going. In today's video, we will explore the strategies and techniques that National Aeronautics and Space Administration has used to keep these Voyager spacecraft operational for more than 4 decades. What kind of challenges did these distant explorers have to face, and how did the mission team implement clever solutions? And what challenges lie ahead for these spacecraft as they continue their journey through interstellar space? At every turn of this story, there is an unsolved mystery hidden. Will these Voyagers be able to reveal even more distant mysteries of this universe to us? How long will National Aeronautics and Space Administration be able to keep these spacecraft alive? The journey of Voyager 1 and Voyager 2 is not just a milestone for space exploration. Rather, this mission teaches us how, even with limited resources and in extreme conditions, innovation and determination can make the impossible possible. The power of radioisotope thermoelectric generators. Radioisotope thermoelectric generator. One key reason why the Voyager spacecraft have remained operational for such a long time is their power source, radioisotope thermoelectric generators. Our traditional solar panels depend on sunlight, but they can't be used in deep space. That's why radioisotope thermoelectric generators have been used in the Voyager spacecraft. Radioisotope thermoelectric generators convert the heat generated from the natural decay of radioactive material into electricity. For the Voyager spacecraft, the radioactive material used is plutonium-238. Radioisotope thermoelectric generators have given the Voyager spacecraft a steady, reliable power supply, enabling it to stay operational in deep space. This technology is especially ideal for missions where sunlight is limited or not available at all, like in the outer planets and interstellar space. The natural decay process of plutonium-238 generates heat, which is directly converted into electricity through thermoelectric materials. Because there are no moving parts, radioisotope thermoelectric generators are highly reliable and durable. However, over time, plutonium-238 decays, which gradually reduces the power output. But still, the Voyager spacecrafts have far exceeded their expected lifespan. This is a result of the durability of the mission's design and engineering. How do radioisotope thermoelectric generators work? Radioisotope thermoelectric generators are a type of nuclear battery that convert the heat produced by the decay of radioactive isotopes into electricity. Each Voyager spacecraft has 3 radioisotope thermoelectric generators which contain plutonium-238 oxide. When plutonium decays, it releases heat, which is continuously converted into electricity through thermocouples. Thermocouples are devices that generate voltage when there is a temperature difference. In 1977, when the Voyager were launched, their radioisotope thermoelectric generators were generating about 470 watts of electrical power. But as plutonium decayed over time, the heat and consequently the electrical power produced by the radioisotope thermoelectric generators gradually decreased. Today, the radioisotope thermoelectric generators are producing about 40% less power than they did initially, which means they are generating only around 250 watts of electricity. But even so, the Voyager spacecrafts have managed their power very efficiently efficiently. The mission team shut down non-essential systems immediately after their use was over, and the instruments have been very carefully prioritized so that they continue to collect scientific data even with limited power. And that's the reason why Voyager 1 and Voyager 2 are still sending us valuable information from interstellar space even today. The long-lasting capability of radioisotope thermoelectric generators has made the Voyager mission an amazing example of how, with advanced technology and smart engineering, we can maintain our existence in deep space for a long time. For power management and to keep the Voyagers operational with decreasing power supply, the National Aeronautics and Space Administration also carefully managed the spacecraft's power consumption. Over the years, the mission team has systematically turned off non-essential instruments and systems to conserve power. This approach has made it possible to keep critical systems like the communication system and some key scientific instruments operational. For example, the Voyager team has turned off the heaters of those instruments that are no longer in use, and also such non-essential systems like tape recorders which used to store data before transmitting it. This careful power management has allowed the Voyagers to continue their mission despite the continuously decreasing energy reserves. Heat and thermal management. Another big challenge with radioisotope thermoelectric generators is managing the heat generated from the decaying plutonium. Just like on Earth, excess heat can become a problem even in the cold vacuum of space. The Voyagers are designed with a thermal control system that uses louvers for heat rejection and insulation to retain heat within the system. And this entire system regulates the spacecraft's internal temperature. This entire thermal management system keeps the instruments and electronics within their operational temperature range. As radioisotope thermoelectric generators' power output drops over time, their heat generation also declines. As a result, keeping the spacecraft's systems warm is becoming difficult too. That's why the team has to maintain a perfect balance between the spacecraft's power and thermal management so that its critical components don't fail due to excessive cold temperatures. Apart from this, the Voyager team has also used innovative methods like adjusting the spacecraft's orientation so that the instruments can be kept a little warm using the sun's heat as well. All of this is like a complex dance where every decision affects the spacecraft's survival and scientific output. Despite all these challenges, Voyager 1 and Voyager 2 have continued their incredible journey to this day. Software updates and problem solving from billions of miles away. Keeping the Voyager spacecraft operational wasn't just possible by managing power, but maintaining the health of their systems and software is just as important. In recent years, the Voyager mission team has solved many problems. Voyager has also received several critical software updates and many creative solutions have been devised. That too, from billions of miles away. Software updates. The most remarkable thing about the Voyager mission is that these spacecrafts have received software updates despite such vast distances. In the beginning, the spacecrafts had only 69 kilobytes of memory, which is quite low compared to today's standards. To maximize the use of this limited memory, the Voyager team designed the software to be highly efficient. After the mission goals kept evolving, the team had to make several software updates so that new tasks could be performed or bugs could be fixed. These updates were sent from Earth via radio signals, which take about 20 hours to reach the spacecraft. For example, when Voyager 1 was given the task of taking the famous pale blue dot image in 1990, the mission team had to specially reprogram the spacecraft so that it could point the camera towards Earth, diagnosing and solving problems remotely. As the Voyagers moved farther from Earth, the communication delay kept increasing, which made real-time problem solving more and more difficult. The team has to send commands to diagnose problems based only on the data received from the spacecraft, and it can take them several hours or even days to see the results. One incident happened in 2010 when Voyager 2 started transmitting confusing data. After analysis, the mission team identified that a bit in the computer memory had flipped from 0 to 1, which was causing problems in the data processing system. A series of commands was sent to reset the system, and after that, the spacecraft returned to its normal operation. This was a huge achievement, especially considering that the spacecraft was about 9 billion miles away from us. Dealing with aging hardware, the Voyager spacecraft are now more than 45 years old, and their systems have far exceeded their expected lifespan. Clear signs of aging can be seen in components like thrusters, gyroscopes, and communication systems, and the mission team has to find creative solutions for them. For example, the spacecraft's thrusters, which adjust its orientation, have been working for 4 decades. Because the thrusters have become inefficient, they require more power, which is often used to perform maneuvers. To conserve power, the mission team reprogrammed the spacecraft so that the thrusters are used less frequently and there is more reliance on the reaction wheels. At another point, when the mission team discovered that Voyager 1's primary communication antenna was becoming off-target due to changes in the spacecraft's orientation. To solve this problem, the mission team developed a new strategy using a combination of thrusters and reaction wheels to keep the antenna pointing correctly. Innovative problem solving. The Voyager mission team had to become creative to solve the problems of the spacecraft's aging systems. In some cases, the team even developed completely new techniques to reduce hardware failures or limitations. For example, when signs of wear started appearing in Voyager 2's gyroscopes, the team developed a new method to determine the spacecraft's orientation. They repurposed the data from the star tracker, which was originally designed for a different purpose, so that the antenna keeps pointing towards Earth and communication remains possible. In 2019, when Voyager 2's power levels suddenly started to drop, causing many of its instruments to shut down, the mission team identified that the spacecraft had triggered a power protection mode due to the sudden voltage drop. To prevent this problem, the team reprogrammed the spacecraft so that critical systems could be given priority and the instruments would remain operational under all circumstances, no matter how much the power levels fluctuated. Overcoming communication challenges. One of the biggest challenges for the Voyager mission team is to continuously maintain communication with Voyager, especially over such vast distances. As the Voyagers are moving farther from Earth, the travel time for signals is also increasing and the strength of their signals is continuously weakening, which is making communication increasingly difficult. Deep Space Network. To communicate with the Voyager spacecraft, the National Aeronautics and Space Administration primarily uses its Deep Space Network, which is a global system of large radio antennas located in California, Spain, and Australia. The Deep Space Network is a critical component of the Voyager system, providing a link between Earth and distant spacecraft. As the Voyagers moved farther from Earth, the Deep Space Network also upgraded its equipment to maintain communication at all times. For example, in 2012, National Aeronautics and Space Administration upgraded the Deep Space Network's antennas with new receivers that were more sensitive and capable of detecting the faint signals from Voyager 1 and Voyager 2. The Deep Space Network's antennas are also equipped with powerful amplifiers that boost the signals sent to the spacecraft, ensuring that commands can reach their precise location even across billions of miles. Signal delay and data transmission. One unique challenge of communicating with the Voyagers is the long time it takes for signals to be exchanged. Significant time delay. Currently, it takes about 21 hours for a signal to travel from Earth to Voyager 1 and another 21 hours for the response to come back. This round-trip delay is almost 2 days, which makes real-time communication nearly impossible, and that's why the mission team has to carefully plan and sequence their commands. To maximize the efficiency of data transmission, the Voyagers use a technique called data rate reduction. In this technique, scientific data is compressed before being transmitted, allowing the spacecraft to send more data in a short amount of time. The Deep Space Network then decompresses and processes this data on Earth, ensuring that no valuable information is lost. Antenna pointing and tracking. To maintain a stable communication link with the Voyagers, precise antenna pointing and tracking are essential since the spacecraft are constantly traveling through space. Because of this, we have to continuously change the orientation of our antennas to keep receiving signals from them, which means the Deep Space Network must constantly adjust the position of its antennas to stay focused on the spacecraft. The Voyager mission team has developed sophisticated algorithms for this, which precisely predict the spacecraft's trajectory and orientation. These algorithms take into account the gravitational influence of planets and celestial bodies as well as the spacecraft's own movement and ensure that the antennas remain accurately locked on their target. In 2020, the Deep Space Network underwent a major upgrade to improve its capabilities, in which the National Aeronautics and Space Administration added a new 34-meter antenna in Madrid, Spain. This upgrade further enhanced the capabilities of the Deep Space Network so that it can easily communicate with distant spacecrafts like Voyagers and ensure that they remain in contact with Earth for as long as possible. Future of Voyager missions. Now, as the Voyager spacecrafts continue their journey into interstellar space, eventually, one day their power levels will drop below the minimum threshold required to operate instruments or communicate with Earth. The National Aeronautics and Space Administration estimates that after 2025, there won't be enough power left in the radioisotope thermoelectric generators to keep the spacecraft systems operational. And when that happens, the Voyagers will go silent and their historic mission, which was providing us with valuable data, will come to an end. But even after the power runs out, the spacecrafts will continue to wander in this infinite space with their golden records, which are a message from our human civilization to future aliens, a testimony of our existence for those intelligent aliens who might someday reach these spacecrafts. The journey of the Voyagers represents humanity's first step into interstellar space, which is beyond the boundaries of our solar system. They have expanded our understanding about the outer planets, about our solar system, and have revealed many mysteries of the heliosphere. This mission also provided us with valuable data about the Kuiper Belt and the interstellar medium. Their legacy will continue to inspire our future scientists, engineers, and explorers. In this entire universe, as far as we know it, Earth is the safest option for us. As we move out of Earth, this space becomes dangerous and mysterious for us. We have been able to learn very little about outer space. That's why whenever an astronaut goes into space, he notices a lot of strange things. Whenever we have sent humans beyond the boundaries of Earth, they have returned with unheard, unknown, and mysterious stories and experiences. And along with that, a lot of data as well, based on which we keep carrying out new developments in space. But is the same story happening with the Voyagers as well? Are they also experiencing some very strange things in this mysterious space? The recent updates about the Voyagers and the commotion on YouTube regarding the Voyager suggest that the Voyager is definitely in some kind of trouble. But how much truth is there in this? After all, what have the Voyagers seen in interstellar space that we, the people of Earth, should be cautious about? What did they see there, and do we need to be afraid of it? Let's find out in today's video. July 20, 1969, when humanity set foot on the moon for the first time, our spirits soared as well, and we felt that we should explore outer space even more. And about 8 years after the success of Apollo 11, we launched 2 such spacecraft that are still considered among the greatest spacecraft in history. We launched the Voyager spacecraft that are still recording data using the old 8-track tape recorder technology. And you'll be surprised to know that the memory of these recorders is about 30 million times less than that of a normal smartphone today. That means they can only store a few bytes of data. Also, the speed at which it sends us data is about 1,000 times slower than a normal 4th generation internet connection today. And even today, both these spacecraft are still working in the harsh environment of space. The Voyagers did their job well, for which they were made. Although both spacecraft, Voyager 1 and Voyager 2, were similar, Voyager 2 was launched to study all 4 outer planets, that is, Jupiter, Saturn, Uranus, and Neptune, and its trajectory was set accordingly. Voyager 1, on the other hand, was sent only to study the inner planets, Jupiter and Saturn. Along with that, the moons of these gas giants were also to be studied, and especially Saturn's moon Titan was given higher priority. Because of this, after Saturn, its trajectory had to be changed so that it could explore Titan. As a result, Voyager 1 could not go to Uranus and Neptune and exited the solar system's ecliptic plane at 32 degrees north. Voyager 1's mission had ended at this point, but we still had the treasure of data sent by Voyager 1. But after this, its twin, Voyager 2, accomplished the historic journey to Uranus and Neptune. These missions were not easy for us at all because no mission had ever gone this far before. We didn't know what was ahead, what the conditions would be like there, or how it would affect the mission. This whole game was running on probability, but the Voyagers accomplished this feat when, in 1989, Voyager 2 did a flyby of Neptune. It was a day of celebration for the Voyager team and humanity as we had measured the last planet in our solar system. We, living on Earth, were the first beings to accomplish this feat. Another thing that will surprise you is that both of these missions were launched for a period of only 5 years. But today, it's been almost 46 years since this mission started, and it's still moving forward perfectly fine. Voyager and its team definitely deserve to be appreciated for this success, because surviving in a place with outdated technology where we've never been before, where every moment is a danger for our spacecraft, and where there's nothing except a harsh environment, Voyagers have been continuously traveling there for the last 46 years. This is truly commendable. Well, one thing is that some people think that Voyagers are missions of the National Aeronautics and Space Administration. As Indians, how can we feel connected to the Voyagers? The answer is that the Voyagers are not just missions of the National Aeronautics and Space Administration, but missions of humanity. The golden record on the Voyagers includes greetings in many Indian languages such as Hindi, Punjabi, Urdu, Bengali, Marathi, Odia, Telugu, Kannada, Rajasthani, and Gujarati. Besides this, Hindustani traditional music Jaat Kahan Ho, sung by Kesarbai Karkar to the tunes of harmonium, sitar, and tabla, has also been included. It is a matter of pride for us that today, the identity of our Indian culture will continue to travel through this infinite space for eternity. After flying by Titan, Voyager 1 kept moving ahead at a speed of 3.6 astronomical units per year, and finally, in August 2012, it bid farewell to our solar system. Voyager 1 was now moving forward in interstellar space. Along with this, Voyager 2 also entered interstellar space about 6 years later in December 2018, and they became the first and second spacecraft to do so. Now both these spacecraft were moving forward into such a dark world about which we knew nothing. At such a distance, anything could go wrong, and finally, the time came when Voyager 1 started transmitting strange and completely nonsensical data to us. What the Voyager team feared was now actually happening with Voyager. To save battery power, almost all of Voyager's instruments were turned off. Only a few instruments are still operating on Voyager today, such as the attitude articulation and control system, which keeps Voyager's antenna pointed toward Earth so that our connection with Voyager remains continuous. But the series of mysterious signals from Voyager 1 did not stop. In May 2022, National Aeronautics and Space Administration detected this anomaly in the data coming from Voyager for the first time. At first, National Aeronautics and Space Administration thought that the reason for the incorrect data might be that Voyager's high-gain antenna was not pointed toward Earth, but looking at the health and condition of the signal, it didn't seem like that at all. Many scientists believe that Voyager was suffering from electronic aphasia. This is a disorder in which the brain of any electronic item fails to communicate in any way, although it still tries to communicate, and this was exactly what was happening with Voyager 1. Voyager 1's attitude articulation and control system was working perfectly fine. Its high-gain antenna was also pointed toward Earth, but it still wasn't able to communicate properly. Now the question was, why did this suddenly start happening to Voyager, which is billions of kilometers away? Although Voyager's science instruments were working, they were collecting data, and the data was also being transmitted. The whole system was in working condition. If something had gone wrong, the entire system should have gone into safe mode, but that wasn't the case either. The Voyager team just couldn't understand this mysterious condition. But finally, National Aeronautics and Space Administration engineers found something that made them think. They discovered a problem in Voyager's onboard system, but this problem could be solved. So the engineers found out that the attitude articulation and control system was sending data from an onboard computer that had failed and shut down on Voyager a long time ago. The scientists now had to tell the attitude articulation and control system to use the right onboard computer. But the scientists were surprised as to why this had happened in the first place. After all, how was this switch between onboard computers even possible in this desolate space? What were those commands that caused the computers to swap, and who gave those commands in the first place? So the answer is this video by Veritasium titled "The Universe is Hostile to Computers." Actually, what happened is that the Voyagers have now left our solar system. They are no longer within the protective shield of our sun where they could be safe from cosmic rays. These spacecraft are now completely exposed to radiation and cosmic rays in interstellar space. And this is where the problem begins. For example, when a high-speed energetic particle like a cosmic ray hits a computer chip, memory errors start to occur in that chip, and these errors keep accumulating over time. Scientists think cosmic rays caused the Voyagers' onboard computers to experience swapping, and that's why Voyagers were sending us incorrect and nonsensical data even though they were functioning properly. A similar incident had also happened with Voyager 2. We all know that both of these spacecraft are very far away from us. It takes about 13 hours for information from the spacecraft to reach us. In such a situation, it's almost impossible to find out in real time what's happening with the Voyagers in interstellar space along the way. And this very uncertainty also gives rise to conspiracy theories. When a glitch occurred in the Voyagers in 2022, the conspiracy theory spread like wildfire across the internet that aliens had located the Voyager spacecrafts and had even disturbed their communication with Earth. Anyway, such claims have no logic and should be dismissed. But there are some people, like this German specialist, who say that these glitches cannot be explained without involving aliens. But as we know, we have a logical explanation better than aliens, which is reliable, logical, and also tested, so I don't think there's any point in believing in these useless theories. But then, we know that people do believe in these theories, and there's a big reason behind this, which is that all these things have curiosity in them. They take our illusions to their destination, the ones we've kept in our minds for a very long time. Just think about it. If they were really aliens, would they only mess with the settings on the Voyagers? If they're really so intelligent that they can reach a spacecraft in space, then why haven't we found any signatures of their technological advancement till now? Yes, aliens exist, but such an advanced alien race is not around our solar system. All those who spread these conspiracy theories either want to sell their books, get views, or increase the television rating point of their media shows. Just like what happened recently, it was going viral all over the internet that the James Webb Space Telescope had proved that the Big Bang never happened. The Big Bang never happened. And believe me, many prominent scientists had to come forward and make statements in favor of science, saying that yes, the Big Bang did happen.
You know, every 6 months goes by and then you see a headline, oh, astrophysicists have to rethink the Big Bang or Big Bang debunked. Or, yeah, it makes excellent clickbait. Yeah, there it is. It's clickbait headlines because it's just really bad science communication in the end of the day.
And actually, the person who claimed that the Big Bang never happened once published a book called Big Bang Never Happened. And this gentleman's name is Eric J. Lerner, whose book you can find on Amazon. So these conspiracy theories are created just to serve their own interests, like he wanted to sell his book. So from here, it means that in the Voyagers, we definitely kept the golden records for aliens, but the thinking behind keeping them is different, and the thinking of these conspiracy theorists is different. Of course, aliens do exist in this universe, but either we haven't been able to find them or they are just too far away from us. But they are not anywhere near our solar system. Keep in mind that here we are talking about intelligent aliens. What do you think about this? Do let us know in the comment section. We have a better explanation for whatever happened on the Voyagers. This is not an alien invasion, and there is no need to be afraid of it. Friends, I hope you have understood the whole matter and learned something good from this video. Friends, if you like this video, please make sure to like it and share it with your friends. For more such informative videos, make sure to subscribe to the channel and turn on the bell notification. Friends, we'll meet again soon with another new informative video. Until then, stay curious, be happy, and goodbye.